Hello everyone. Welcome to the solution of LeetCode problem 682 named baseball game. In this problem, you are keeping the score of a baseball game with strange rules. Here, at the beginning of the game, you start with an empty record. Now, you are given a list of strings of operations where operation of I is the ith operation you must apply to the record and in the following rules. Here, if the operation I is an integer x, that means we have to record a new score x. If the operation I is plus, that means we have to record a new score that is sum of the previous two scores. And if our current operation is d, that means we have to record a new score that is double of the previous score. And if our current operation is c, here we have to invalidate the previous score and removing it from the record. After that, we have to return the sum of all the scores on the record after applying all the operations. The test cases are guaranteed such that the answer and all intermediate calculation fit in a 32-bit integer and all operations are valid. Here, the examples are, in the first example, the operation is 5, 2, C, D, and plus. So here, 5 is an integer, so we have to add 5 to our record. Now 2 is an integer, so we have to add 2 to our record. Till now, our record holds the value 5 and 2. Now, the third string is C, that means we have to remove the latest integer value or the previous score. So now we have to remove the value 2. So our record is now only 5. Now it is D. So we have to make the double of our previous score. So the double of 5 will be 10. And our new record is 5 and 10. Here we have to add the 10 into the record. Now there is the addition operation. So here we have to add the previous two elements in the record, which is 5 and 10. So their addition value will be 15. And we have to add this addition value into the record. So till now, our record holds 3 value, which is 5, 10, and 15. So the total sum will be 5 plus 10 plus 15, which is 30. So in this case, we have to return 30. I hope you understood the problem statement as well as the examples. Now the constraint are, the operation length can be in between 1 to 1000, and each of the operation is either C, D plus or a string representing an integer in the range of minus 3 into 10 to the power 4 to 3 into 10 to the power 4. And for operation plus, there will be at least 2 previous records on the record. And for the operation C and D, there will be always be at least 1 previous score in the record. I hope you understood the constraint. Now let's move on to the algorithm. Now, to understand the algorithm, we have taken the first example. Here, it has 5 value, which is 5 to C, D, and plus. Now, if we want to solve this kind of problem where we have to make the calculation with the previous value, we can use the stack data structure. It is the convention. Either we can use the simple vector, but to utilize the data structures, here we are using the stack data structure. As is this kind of problem, we have to deal with the previous records or the previous scores. So now our input is this. It has 5 string, which is 5 to C, D, and plus. Now we are using one stack here. So suppose we have to iterate all of the element from left to right. Now, suppose currently we are at this element 5. So it is an integer value, right? So we have to add 5 to the stack. Now, currently we are at this element 2. It is also integer value. So we have to add 2 to the stack. So till now, our stack contains two elements, which is 5 and 2. Now, our current pointer will point to the element C. So, the rule for the C is, if we find C, then we have to invalidate the previous record. So here, we have to invalidate the previous record, which is 2. So that means 2 will be discarded. So here we have to remove 2 from the stack also. Now our current pointer is pointing to this element D, where for the rule of the D is, we have to make double to the previous element. So here, till now, our previous element is 5. So here, we have to take the top element of the stack, which is 5, and we have to make it double. So 5 multiplied by 2 will be 10. So we have to add 10 to the stack. Till now, our stack has two elements, which is 5 and 10. So now we are in the last operations. So currently our pointer is pointing to this addition. So here for this addition, we have to add the previous two element and insert the value into the stack. So here the previous two element will be 5 and 10. So till now we have to add these two element, which is 5 plus 10, which is equal to 15. Now we have to add 15 to the stack. So now we have completed iteration all of the element into the given string, and we have to make the summation of all of the element presented in the stack. So till now there are 3 elements presented, which is 15, 10, and 5. So the summation of all of them will be 30. So in this problem, we have to return 30. I hope you understood how we can solve this problem by using the stack data structure. So let's move on to the algorithm and the code. Here, the code is pretty simple. At first, we are given a function named callPoints, which has a vector of strings. It is operations. Currently, we are initializing a variable sum to 0, which will store the sum. And we are taking a stack of integer types. And we are iterating each of the element in the operations. If our current element is positive, that means we have to take the top element of the stack and remove it. And then we have to again take the top element of the stack. And we have to push that first top element and push the summation of a plus b. And for each of the element D, we have to make the top element double and push it into the stack. For the element C, we have to remove the last element or the top element from the stack. And otherwise, if it is integer value, that means we have to push the current integer value into the stack. Here, we are using the string to integer function, which is used to convert our string representation of an integer to an integer form. After that, using this loop, we will add all of the elements presented into the stack. And finally, we have to return the summation. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element into the operations, and the space complexity is also big O of n because we are using additional memory of a stack, and in the worst case, the size of the stack can be equal to the size of the input string. So here, we can say that the space complexity is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.